Okay, here we have some extra problems for Wednesday, the 21st of November. So in the first problem, first example, you're going to buy a house and finance $265,000, 3.8% for 30 years. So in this problem, N is going to be 12 times 30. I percent is 3.8. Now, if we draw the timeline, we have now and 30 years. And the present value is always what you finance, which is $265,000. And then beginning next month, 1 month from today, we'll start making payments. And when we walk in and make the last payment, our future value would be 0. So there's the setup for the timeline. Now, the present value is the cost of the house. That is considered a source of income. The value of the house is coming to you. And then we'll have the payment. And again, when we walk in and make the last payment, the future value will be 0. The debt is completed. And then PY equals CY is 12. So enter that into the calculator, into the app, and you get a minus 1, 2, 3, 4, 7, 8, 6, 9, 8. Okay, so therefore you'll get an answer for the exam of 1, 2, 3, 4, 79, using the normal rounding scheme. So your payment would be $1,234.79. Now, part B, what is the total interest paid for the 30 years? Well, contrary to what's in WebAssign, we would have to take this value here and multiply by the number of payments, which is N. What we're going to do is just take this payment, multiply by 360. So the total paid is going to be 360 payments times 1, 2, 3, 4, 79. And that's going to equal 444,524, 40. So you finance $265,000 and you're going to pay back total almost $450,000. Now, WebAssign would not accept that answer, but that's good enough for us because see, even if you use all the digits in this payment and multiply this by 360, it's still going to be incorrect. So it's going to be a little off in both cases. So we're just going to do this. Now that's the total amount you paid. So now you want to take the total amount you paid and subtract what you financed. So your total interest in this situation is about $179,000, 524.40. And that's good enough for us. Okay, now next part. Suppose you pay an extra $200 each month to the nearest year. How long? Until the house is paid off. Well, go back up to this situation, get all this typed into the calculator, and move the cursor down to here, move it all the way over to the end. So we're going to take this. Now I'm just going to write down this part. So you've got the cursor right out here. And what we're going to do is go minus 200. So we're going to pay an extra 200 each month, each and every month. Now this has to be negative because this is negative. If this were positive, then this would be positive. We're going to increase the payment by $200. So that's going to give us a minus 143478698. All right. Now go back up to N and solve. So you were here and you tacked on $200 to this on your calculator, and now the only other thing we're going to see is what effect that has on the total number of payments. So we're going to solve for N, and what you will find is N is equal to 278071433. So that's about 278 payments. But now a payment is each month, and in the problem it says to the nearest year, how long will it take to pay the house off? So what we need to do, this is month, we need to move the cursor all the way out here, hit the division key, and 12. And when you do that, it gives you 23.17261969, and this is going to be years. So rounded to the nearest number of years, it'll be 23 years. So if you can pay an extra $200 a month, it's going to cut about 7 years off the term of the note, off the length of the note. So that's going to save you 7 years of payments, and it's going to save you 7 years of interest, just for an extra $200 a month. Now, if we keep everything the same, what if we decide to finance for 200 years? What's the payment? For 20 years. What if we decide to finance for 20 years? Well, then N will be changed to 12 times 20, and everything else will be the same. I% is 3.8. Present value is 265,000. Payment, future value is 0. It will be paid off at the 240th payment, and the PYCY terms are 12. Now, what you'll do, you'll find that the payment is going to be 1578.0582. So that would give us an answer of 1578.06. So if you finance it 30 years, it's about $1,230. If you finance for 20 years, 10 full years less, it's going to cost you about a few dollars short of $1,600. Okay. Now, if you do finance for 20 years, how much interest do you save by financing for 20 years? You're going to make 10 less years of payments. Okay, so for 20 years, the total that's going to be paid is going to be 12 times 20, 240 payments. Each one is $1578.06. And that comes out to $3,787.34 That's the total paid. Then the interest at 20 years will then be the $3,787.34 minus the cost of $265,000, and that's going to be $113,734.40. So if you finance for 20 years, it's $113,734 in interest. Now, if we compare this back to the situation where we financed for 30 years, and if we subtract those two values, the interest saved comes out to be $65,790. Wow. That's a lot of money. The moral of the story is, if you can get by financing 20 years, finance at 20. If you can finance it 15 years, you're going to save a ton of money in interest. Now, here's kind of a depressing final part of this problem. Suppose you decide to finance 30 years. That's the way you want to go. And you faithfully make payments for 20 years. You're going to make 20 years worth of payments of $1,234.79. You never miss a payment. You make payments for 20 years. When you walk in and make that 240th payment, how much do you still owe on the house? Well, you financed it for 30 years. You've been making payments for 20 years. That's 2/3 of the time. You would think you've paid off 2/3 of the house. No, sorry, doesn't work that way. Let's take a look at how to do this. If we draw a little timeline here, now this one's really tricky. The present value is $265,000, and you're going to make payments for 20 years. Okay. Now, each of your payments are going to be this 1, 2, 3, 4, 79, and you're going to make a payment each and every month. And we want to know, when you walk in and make the 240th payment, now I'm using this value that's right up here because I'm going to have all this on the screen. What I want to do is calculate the future value. I'm going to calculate this future value here. It's not going to be 0, is it? Because you've still got 10 years worth of payments. So let's put all this back up here. N in this case is going to be 12 times 20, because we've made payments for 20 years. Interest rate is the same, 3.8. Now for the payment, present value, for the present value, I'm going to use the 265,000. And for the payment, I'm going to use the value found up here in the first part. In part A, I'm going to use a minus 1, 2, 3, 4 78698. And the only reason I'm doing that is it's still on the screen from when I worked it earlier. It's still on the calculator screen. Now you go down here to future value and solve, and you get a negative 123,112,6334. So it turns out you're going to owe, after making 20 years worth of payments, you're still going to owe $123,112.63. Almost half. So even though you've made 2/3 of the payments on the original note for 30 years, you still end up owing almost half. The reason for this is, back up here, this payment is broken into two parts, interest, and then what's left reduces what you owe from the $265,000. And the way everything is set up, the institution that loaned you the mortgage, the money, gets their money up front. They get their interest up front. So for a long, long time in your payments, if you were to write down each time you make a payment and how this is split up, most of this is interest. Quite small of this actually, a quite small amount of this, $1,200 actually goes to reduce this debt. Okay, I hope that helped. That's the end of the first example. All right, here in the second example, we have a two-stage problem. Okay, now I usually just divide the paper into two parts, and in this one you've started a job and you want to save $480 a month into an IRA, Roth IRA, and you're going to do this for 32 years. So $480 payments each month for 32 years. Interest rate of 4% for all parts of the problem. When you retire, you want to withdraw an equal amount each month that will completely exhaust your savings after 12 years. Okay, so what amount are you going to be able to withdraw when you retire so that after 12 years of monthly withdrawals, there's no money left? So let's split this up into when you're working and when you retire. Okay, we need timelines for each. It doesn't really matter which one we do first. Let's just do the working first. So if we look at the working side, and this is going to go on for 32 years. Now, at the start, present value is 0. You have nothing in the account. So then each month, you're going to deposit $480. And I'm going to make those negative. And then, of course, we will be able to calculate a future value, which is going to give us the amount in the savings account the instant we walk in and make that last deposit. Now, let's look on the retirement side. I'll do this in a different color ink. The timeline is going to look like this. Let's just put the start of retirement. And then each month, you're going to go get a withdrawal. Same amount. And you're going to do this for 12 years. And the way the problem reads, when we go in and get our last withdrawal after 12 years, of course, there's nothing in the account, so the future value is 0. Now the question is, we need to know how much money we can have before we can calculate the withdrawal. We need to know how much money we have to start here. We don't know that. So here we don't know the present value, that's unknown, and we don't know the amount. Well, of course, the trick is when we calculate this future value, we're going to set that equal to the present value in retirement. So I guess we're going to start here. We're going to get our numbers from here. So N, it's a monthly withdrawal, monthly deposit, and we're going to do that for 32 years. Interest rate all through the problem is 4%. Present value is 0 starting out. Now the deposit is minus 480. And we want to calculate the future value. We want to see what this will accumulate to over 32 years. PY and CY are going to be 12. Well, we throw those numbers into the calculator, and it gives us 372814 8544. And the trick to doing these problems in WebAssign is we're going to copy that number over to the present value on the right, and we keep all the digits to get the answer that WebAssign gets. Okay, on the retirement side, we're going to make monthly withdrawals, so that's 12, and we're going to do it for 12 years. Interest rate, 4%. Now for the present value, we're going to copy this number directly over here. And I'm going to make it negative. If I make this negative, then our withdrawal will end up positive. If you want to keep this positive, then the withdrawal is negative. It doesn't have any effect at all on the problem. But I'm going to introduce a negative there, and you don't have to. Okay, now the payment's what we wish to find. And of course, when all is said and done, the future value is 0, you're out of money. And of course, the PY, CY remains unchanged at 12. Okay, you move that up in your calculator, solve for the payment, you get 3264. 099814. So therefore the solution, in retirement, you're going to be able to withdraw $3,264.10 a month for 12 years. And when you go in and get the last withdrawal, there'll be nothing in the account and you're out of money. All right, in the final example, this is sort of the inverse of the previous example. In this situation, you'd like to retire, and when you do, you want to be able to withdraw $3,800 each month for 10 years from the retirement account. At the end of that 10 years, the balance in your retirement account is 0. All the money's going to be gone. So in your current job, how much should you save each month for the next 28 years so that you can do this? So this is going to be another two-stage problem. And I recommend just drawing the timelines. And let's just see what we need here. So let's call this side working. And over here, retirement. Okay, let's do the working side first. We could do either side first. It doesn't really matter. Okay, so this is now, and the present value is 0. You're starting off with nothing in this job. And each month you're going to deposit into an account of some kind. It doesn't say in this problem. And you're going to do this for 28 years. And when you do, there's going to be an accumulation. And that's about all we can say so far. Now, on the retirement side, if we draw in the timeline, this is going to be the start of your retirement. And what you're going to do then is withdraw $3,800. Now, don't get caught up on whether to make that 38 plus or minus. It doesn't really matter. I'm going to make it positive here. Now, when you walk in and withdraw that last 3,800 at the 10-year period, the future value will be zero. There's going to be nothing in the account. So you're out of money. So the question is, how much do you need to be able to do this? Now, we can calculate that. We can find this present value. And then what happens is we're going to use this present value. We want that present value to be the amount that we accumulate in the working scenario, and then we're able to solve for the payment. So in this one, we want to begin here. All right, this is for a 10-year period. Withdraw each month for 10 years, so that's 12 times 10. Interest rate is 4. Present value is what we're going to calculate. Your withdrawal is going to be $3,800. And when you make that last withdrawal, your future value is 0. Okay. So we move the cursor to here and solve, and we get a minus 375,326,6645. All right. Now on the working side, you're going to make a deposit each month for 28 years, so 12 times 28. Interest, 4%. Present value now is 0. When you begin, you have nothing, of course. And here the payment is what we want to know. Future value. Well, the future value in this scenario, what we want to end up with after saving for 28 years, is going to be exactly what this present value is. So we're just going to copy this number, 375,326,6645. And this is what you have to do in the WebAssign two-stage problems. If you don't copy all these digits, you will get the wrong answer. Once we have that for the future value, then we come up here and solve for the payment. And this is going to give us 607,57506. So what we need to do while we work, we need to save 607.58 each month. So that's quite a problem. That's quite a feat to be able to do something like that. And when you folks get out and get your job, you want to think this way. You don't want to rely on the government or relatives for your savings in retirement. Everyone have a nice Thanksgiving.